Okay, some last minute advice for Extension 1 students. This was the last question on the 2021 exam. The average result was 0.2 out of 2, and it's really not that hard as long as you know a little trick to it. So let's unpack it together. We have a polynomial g of x given by this cubic equation passing through the point 1, 3. Find the gradient of the tangent to f of x, which is the inverse of g multiplied by x at the point where x equals 3. Okay, so first off, I'm going to make my life a little bit easier. I'm going to say that h of x is going to be the inverse of g of x. This is just a little notation thing, and just trust me, it makes the algebra a little bit easier because having to write the derivative of an inverse function is really confusing for most people, me included, and this is going to simplify it a lot. Okay, so that's optional, but I'm going to do it. So now our function has now become x times h of x, where h of x is the inverse of g. Now, to find the gradient of the tangent at this function, we need to differentiate the function, and we have a product here, so we're going to need to use the product rule to differentiate. Okay, so let's differentiate the x first and make that a 1, and let's leave the hx alone. Now let's add to that the opposite. Let's keep the x alone, and let's differentiate the inverse to be h dash x. Okay, so now to figure out the gradient of the tangent at this point, all I've got to figure out is what is 3 subbed into this expression. So f dash 3 is going to be the inverse function evaluated at 3, plus 3 times the derivative of the inverse at 3. Now let's unpack how we're going to figure these out. First of all, we know that this original function, g, passes through 1, 3. That tells me straight away that the inverse function is going to pass through the inverse point, which is 3, 1. Okay, so h of x, which was the inverse, passes through 3, 1. So h of 3, which is just here, is just going to be equal to 1. Now let's talk about the derivative, okay? So the way you want to find the derivative of the inverse at a point, and this is really important, it's been in a lot of exams recently, so h-3 will be the reciprocal of g-1, okay? That right there is very important. If you want to find the derivative of the inverse at a point, it's the reciprocal of the derivative at the original function at the original point. And that's very confusing, which is why this is a band 6 question or an E4 question, okay? So let's differentiate the original function, g of x, to get g dash x. That becomes 3x squared plus 4. And so now we're going to find g dash of 1 by subbing in x equals 1. If we sub in x equals 1, we get 3 times 1 squared plus 4, which is 7. So that tells me that the derivative of the inverse at the inverse point, which is 3, 1, is going to be the reciprocal of 7. So h-3 is going to be 1/7, and it's that easy, okay? h-3 is 1/7. Now we can go back to our derivative, and we can find our answer by doing h of 3, which is 1, plus 3 times h-3, which is 1/7. And so we end up with a final answer of 1 plus 3/7, or 10/3 for 2 marks. If this comes up, I hope this helped, but good luck for your exam. If you're freaking out about Extension 1, check out the videos on my channel because there's heaps on there that can help you before your exam. Thanks for watching.